Hi, everyone. Thanks for attending. We'll be starting in just a few moments.
Morning.
Good morning.
How are you?
I am doing well.
Awesome.
And thank you all for joining. We'll be starting in just about 6 minutes, I think, to give everyone time to come in. And Mark, do you have your screen ready to go? I'll change over and let everybody see your screen as the intro.
Oops, sorry about that. I was muted. Yeah, I'm going to
It's okay,
I'm just gonna walk through my slides about a minute, and then I'll present.
certainly. Again, thank you all for attending. Looks like we have about 40 people on. Good turnout. We're expecting many, many, many. This is an exciting time for SolidCAM. We appreciate everyone joining us. Welcome, everybody, and thank you for joining us. We'll be started in just a few minutes.
Hey, Sean, could you do the share again for me, please? Thank you.
And Mark, I'm going to take a few minutes to introduce Solid Flow to our audience and introduce you for just a minute or two, and then we'll let you do your thing.
Sounds good, Sean. Thank you.
So it looks like we have about 70 people in attendance. That's a good turnout so far. We are expecting quite a few more. So we'll get started in just a minute or two to let some people come in the door at the last second. It's kind of how these webinars work. So we'll get started in just a few. So it looks like we have just a few more people entering in. I appreciate that. So we'll be started in, I would say, just about a minute. So again, we're getting a steady stream of new attendees. Really appreciate you all joining us this morning. Okay. This webinar is being recorded, so it will be available to those people afterwards as a recap. And for those who don't know me, my name is Sean Mimudis. I am the COO of SolidCAM for the US and Canada. And welcome to the Protected Flow or Solid Flow webinar. This is a historic day for SolidCAM. SolidCAM has been the leader in integrated CAM for a long time. And the way that we've become the leader is really Emil is extremely interested in the customer perspective. So he spends a lot of time talking to customers, experiencing what their challenges are, asking them questions. And what he determined was, as good as the CAM system is, and SolidCAM is the best, but there's still some holes in the manufacturing uh, program. So there's still some challenges that exist that SolidCAM by itself could not help. So Emil went and looked for an aid that would help companies in their scheduling and to understand exactly where projects were within the manufacturing process. And he searched very high and very low. He searched it all over for the best solution. And that best solution comes from a company by the name of Lillyworks. They started in 1960, so they've been doing this an awfully long time. And it's a family, it started with, back in 1960, and it's a family effort, much like SolidCAM is. They have a lot in common with SolidCAM with a huge dedication to their customer base, but they can now handle, or SolidFlow can now handle things that, again, just the CAM system can't. So it's very complementary, and it will provide an entirely, and I said this is a historic day because it's an entirely new solution for the SolidCAM customers with SolidFlow. So it's my great pleasure to introduce Mark Lilly from Lillyworks. He is just incredibly dedicated, and he grew up in this business, incredibly dedicated to providing visibility and insight into the scheduling and making companies be able to deliver on time and take the guesswork out of trying to manage their process. So Mark, thank you for joining us today. And I know I'm extremely excited to be able to see your presentation. And I know we have over 100 attendees that are looking forward to seeing it as well.
Terrific. Thank you so much, Sean, for that really wonderful introduction. I am Mark Lilly, President and CEO of Lillyworks, and I too am very excited to be here today and have the opportunity to present really a very strong collaboration between Lillyworks and SolidCAM, taking our protected flow product and really making that a product offering for all SolidCAM customers, prospects, and resellers as solid flow. And we'll see how that works as we move into it. Really the topic of the presentation and the way we present this is how to solve the late problem in manufacturing for good. And we will talk about the late problem in very short order. A little bit about Lillyworks. We are the creators of actually several manufacturing ERP software applications. One was ProfitKey. Another is called Visual Manufacturing, now known as Infor Visual ERP, owned by Infor. Both of these products are actually still being sold net new out in the marketplace, and both of them have thousands of customers, manufacturing companies using them, and over tens of thousands of users. They both also have really excellent traditional finite scheduling embedded in them. In fact, our team here at Lillyworks actually got a patent on manufacturing scheduling. So we know scheduling very, very well. What we have found, however, is that in spite of this wonderful scheduling functionality that ProfitKey and Visual has, and frankly, a lot of other ERP systems have very good finite scheduling, capacity scheduling embedded in them, what we find is that most manufacturers struggle with the late problem. They struggle to utilize these tools to address really what they're trying to fix by using a scheduling type program. How do you know if you have the late problem? Well, certainly your on-time delivery to your customers may not be where you'd like it to be. Your lead times are longer than you'd like for manufacturing in particular. You'd like to be able to quote shorter lead times to be more competitive in the marketplace. You have high WIP or work in process inventory. You've just got a lot of material out on the floor and what seems like a lot of bottlenecks, or maybe bottlenecks move from week to week, even day to day within your production floor. So as a result, you've got a lot of expediting to do. It feels like you're always trying to catch up. You're always behind the 8 ball, trying to get those orders out on time. As a result, sales and customer service is frustrated. They're getting the calls from the customers saying, you know, where is my order? When can I get it? And oftentimes production struggles to give an answer that that not just that would satisfy, but even that is somewhat believable, right? And as a result, you may be not being as competitive as you wish, winning new business as you'd like, possibly might even be putting existing customers' business at risk, and all the financial issues that come with that. So we're really looking to address this and turn it around. So let's take a quick look again at what manufacturers have used in the past to try to solve the late problem. As I mentioned, the traditional finite capacity scheduling model is embedded in just about every ERP system out there. It is available as bolt-ons to existing ERP systems, and many, in fact, most companies have tried this type of tool. I won't go into this entire list. We're going to cover some of this as we go through the presentation. In general, the functionality was originally designed in the 60s and the 70s and even the 80s, where when for the most part a lot of manufacturing was for standard products. Now we see most manufacturing is custom in some fashion, high mix, low volume type manufacturing. There's some other reasons. The bottom line here is that, and what manufacturers find is that you're using this program to try to create a plan, a schedule, and then you're taking that plan, typically in the form of dispatch lists you might print out from the ERP, bring those out to production, and what happens once a plan gets out into production? Well, something changes, right? A customer calls and changes the due date. A material doesn't show up. A tool breaks. So the production is just so dynamic. Even if you were to come up with a perfect plan, which of course doesn't exist, but even if you were and brought that out into production, things are so dynamic that you'd feel you'd have to go rerun that plan probably 15, 20 minutes after it got out there, because things change so frequently. So as a result, this whole approach, and again, it's not the software per se. The software is doing what it was intended to do. It's more this approach of trying to create a plan in advance and then going out to production, attempting to execute that plan. So as a result of this dynamic environment and folks getting frustrated with the static nature of a plan, most companies revert back to trying to manage production and scheduling on spreadsheets or manual whiteboards. So how do we fix this? What I'm going to spend the next few slides on is introducing an entirely different approach, and we call this the dynamic production method. The dynamic production method uses 3 principles that work together in conjunction with each other that fix the late problem in fairly short order, in a relatively quick fashion. The dynamic production method is founded on 3 performance principles: pragmatic planning, So we're going to not only acknowledge variability, things like I just described, customer calling, somebody calling in sick, material not showing up, machine breaking down. We're not only going to acknowledge that those things happen in production, we're going to actively and proactively anticipate it. Proper pacing. And what this means is we're going to control how much material goes into work in process. We'll be talking about that more and why that's important. Then there's finally predictive prioritization. And this is essentially the prioritization method that we're using to determine when we should start jobs in production, when we should even release them out to the floor. And then once they are released, in any work center, if you've got 2 or 3 or 5 or 10 jobs lined up in that work center, how can you be confident as to which one of those you should select to put on that machine next? Okay? And that's that third principle. So we're going to put the entire traditional finite scheduling capacity planning model aside for the moment and move into real-time flow. Let's talk about pragmatic planning. So this is, let's say this is a work order, right? A job, a production order. So here we've got a material, say it's some bar stock. I'm gonna cut it into pieces. I'm gonna send it over to the CNC milling. I'm gonna turn it in lathe department, and then I'm gonna package it out. Okay, pretty simple, few steps job here. Now, if I have a timeline, and I have a due date, and let's say this represents the work that needs to be done. So each of these operations has embedded in it, an estimated setup and runtime. I multiply it by the quantity, even though that says 1. Let's say I'm making 10 of these, so 10 times the runtime on each one of these. Maybe I've got, what is this? This is like 1, 2 and 3 days of work that needs to be done to get that job done. Okay. Is this the way I'd want to plan it? Is this the way I'd want to execute this job? In other words, in a traditional finite scheduling program, in a backward schedule mode, I would assume, or I would plan to finish the last operation of every job on its due date. Now, when you look at this and you think about that, does that make, would you really do this in reality? If these were the actual estimated times on each of the machines in each of the departments to get to, once it's being worked on, would you actually release this on Tuesday around noontime and expect it to get done on Friday in perfect sequence? Probably not, because you probably have tens, if not hundreds, maybe thousands of other jobs out in production. And in order to get these 4 operations complete, I'm going to have contention in between operations. I'm going to have bottlenecks. I may have that variability we talked about where things not going according to plan. So I'd want some time protection right here. I'd want a buffer that's protecting me, making sure that I feel comfortable that I'm going to get this work done by that due date. Okay. And this is what we do when we interface with your ERP. If you have an ERP and work orders in it, we'll talk about this. We're going to bring that information right over into our tool, into SolidFlow, and initially and automatically create this structure, what we call an execution plan. So the execution plan is the work that will need to be done, okay, based upon the estimates and the quantity being produced. The due date is the anchor point, and then time protection to make sure we feel comfortable, you feel comfortable, you and your production folks feel comfortable that you're going to be able to get that work done by that due date. Okay. Now, note that we're not, by introducing the concept of that buffer, note that we're not adding more time to the operations. We're not adding more time to your lead time, for example. Okay, and to clarify that and to show that, let's talk about that a little bit. In fact, let's do an exercise where you ask yourselves, what is as a manufacturer, take one of your maybe average products, and what's a lead time on an average product that you produce today, right? Oftentimes we hear 6 weeks, 8 weeks, 12 weeks, something like that. So let's say in this case, we've got a 6-week lead time. Well, of that lead time, if nothing else were in the shop, it was only that job, only that work order, and all the machines, all the people were standing at the ready to do that job, you had material, how long would it actually take you to get that job through all its steps needed to be completed, okay? So we call that the touch time. So what is your touch time versus lead time? When we ask manufacturers, machine shops this question, we often get out of a 6-week lead time, the actual touch time is oftentimes maybe a week, sometimes a couple few days, sometimes it's even hours, right? And yet we're quoting, we know that once we release it and in order to get it out of production, it's actually going to take some time. So that's what we might look at initially, in fact, to establish the size of that buffer. And then that's a decent starting point. If we feel comfortable, we could even reduce it a little bit, and we'll show you why you might want to feel comfortable doing that initially. If you don't, that's fine too. But that's the I just want to clarify that we're not adding time to your lead time here. We're taking your existing lead time and splitting it out into the touch time and what you're using today, whether you're doing it consciously or not, as a buffer time against your due date. Let's talk about proper pacing. What this means is what we find is a lot of companies have this quote unquote, I'm doing air quotes with my fingers, intuitive idea, right? That, gee, as soon as we get material out in production, the sooner it's going to come out the other side is finished, right? Well, unfortunately not. What we find, and there's actually a law out of mathematical Q theory called Little's law that talks about this, and that is the more people or items or things you introduce to a system, and in Q theory, a system might be when you go to the bank at lunchtime, a highway, a line at an amusement park, right? So the idea is the more things that enter the system and the faster they enter into the system, the longer period of time any one of those things will be in the system. So for example, you go to the bank at lunchtime. A lot of other people go to the bank at lunchtime too. So the queues, the lines are going to be longer. The more people in the bank, the longer period of time you're going to be in the bank. So what we often find is here's our due date. And just as an extreme example, I said, well, you know, how long should this buffer be? Boy, what if I want to be really safe and give this 20 weeks of buffer time against just these 2 days of work? Okay, so, but when you think about it, that might be what you may be doing, not so extreme, but if you're releasing material as soon as it's available or as soon as you get the order with really not much more thought than that, then you may be introducing a lot of material too quickly into production. And you're essentially creating a traffic jam in your production facility, okay? So remember Little's law, the more material you send out into WIP, the more jobs you release out onto the floor, the longer period of time any one of those jobs is going to be in WIP, okay? Just like if I were one of the cars in this picture, there are so many cars, just the sheer volume, I know I'm gonna be on this, you know, say 5 mile stretch of highway, probably for, you know, a half an hour instead of just 5 minutes if there were much fewer cars and we were allowed to travel at, you know, 60 or 70 miles an hour. It's the same way in the production environment. The fewer jobs we release, the faster any one of the jobs in WIP is going to be able to flow through all of its work centers it needs to get through to get done. So if we have a reasonable amount of buffer, and I'm not I have a very short buffer here for, you know, I've got about 2 or 3 days of work, and I've got just maybe 5 days of buffer. this may be very short for some people. For some, it may be longer, but this is just to show the example. Here's my due date, the work that needs to be done. If this is my comfortable amount of buffer time, whatever it is, okay, but as long as we've consciously talked about this, and this is part of our implementation process, where you tell us, you tell the system how big these buffer sizes should be. So if I've got a comfortable amount of buffer here, then what do I have over here on the left-hand side of this execution plan? Well, I've got a really good point in time, an objective point in time that is the right time for me and my production facility to start this job. And really, if I start it any sooner, then I'm really just clogging up WIP. I'm confusing the true priorities, confusing it with other priorities that really need to be worked on out there. And I'm likely creating false bottlenecks and reducing my overall flow through production. So very, very important principle. What we find is that, and this is, we implement this in 3 phases, and what we find is that most of our customers see by putting this in place and actually consciously waiting to release certain work, WIP reduces dramatically, and just by reducing WIP, there comes on-time delivery improvements and overall flow and lead time reductions as well. What often happens over time as well is that you'll find, say on a 6-week job, if you start even just doing this on what your lead times are today, that is controlling when you're actually going to release work out into production, then you'll find you need a smaller buffer time because since you don't have so much in WIP, your bottlenecks may reduce, and you actually need a smaller buffer to get all your work done on time. Okay, the third point is predictive prioritization, and this is really looking at how we prioritize work. So we've talked about when the right time to release work is, but we've also need to see once work is released, how do you decide which job to work on next once it is out in production? And we have a method called the threat level that allows us to do that, okay? So when you look at most scheduling software, scheduling tools, scheduling methods, pretty much unanimously, the prioritization method is the due date, which seems to make perfect sense. It's a very important piece of information. It's your commitment to your customer, or if you're make to stock, it's when you want a replenishment quantity into inventory. So it is a very important piece of information, but the problem with it is it skews the true priorities, especially in a high mix environment. And let's talk about why that is. So here's an example where I have 2 jobs, okay? I'm in a high mix environment. So I've got a longer job and a shorter job. My shorter job is due right here. This gray line is today. And I've just got a little bit of work left. Okay, here's the work I needed to get done. Here's the work I have left. And I've got a fair, relative to the work that I need to get done, I've got quite a bit of buffer remaining to my due date. In this job up here, again, here's today. Looks like I haven't even really started it. I still have all these operations still need to get done. So you can see that's penetrating deeply within my buffer, and I really only have a very short amount of buffer time remaining, especially compared to the amount of work that I have left to be done. So my due date is way out here, 6 weeks from now on this one. My due date on this one is only a week and a half. If I were using a typical scheduling tool, well, I'd work on this one, right? Because it has a much earlier due date. In fact, I may have many orders that are due prior to this due date, and I'll be working on those. And what's going to be happening while I'm working on those? Well, this timeline is going to continue to push forward. This work isn't going to get started, and you can see where this is going. That buffer is going to go away, and that's going to penetrate my due date into after the due date. And and then I'm not late on it now, but in very short order, I will definitely be late. I'm going to be late on that job because of how much work I'll still need to be done, okay? So this is why prioritizing by due date can not only get you in trouble, it can also emphasize and create that environment where you're always trying to catch up, right? Because you're always focusing on these jobs with the earlier due date at the expense of this one with the later due date, but you realize when you actually look at it, it should have been started way back here. Okay. Those are the 3 performance principles that, when applied together using the dynamic production method, these 3 principles are going to improve your on-time delivery, reduce your lead times, improve your flow through production, and make your customers happier, and hopefully your sales and customer service folks happier too, because you'll be satisfying your customer due dates in a much better way. Let's talk about implementing the dynamic production method, and we do this with a software tool, and that software tool is SolidFlow, okay, powered by our software, Protected Flow Manufacturing. And Sean's wonderful introduction, thank you for that. We are very excited to be partnering with SolidCAM to introduce SolidFlow as a part of their portfolio, their platform, to help manufacturers improve their production performance. SolidFlow is implemented in 3 phases, okay? Phase 1 is the here and now, what needs to be done right now, okay? So you can, we'll show you a tool. You can see all of your jobs going on in the shop at one time, or specific to any department, work center, machine, even person, the priority list for them showing what they should be working on right at this moment, okay? There's a phase 1A, this is optional, and that is, are materials a concern for me, okay? If you're a machine shop and you know you can get the materials that you need whenever you may have plenty in inventory already, or you can just go down the street, or maybe it's a day lead time for your materials, not a problem. Many customers now, however, many manufacturers are struggling with the supply chain issues, so materials are a big deal. Maybe internal bottlenecks that are causing delays, but even more so, it could be materials. So we will look at materials as well. But it is optional when you implement DPM using SolidFlow. Phase 2, so phase 1 is really focusing on the here and now. What should I be doing right now? We're focusing on the execution of production. Phase 2 is where we look out into the future and say, what will our production look like in the future? If I execute based upon this method, what will it look like? When will my orders get done based upon all my capacity constraints? What will my bottlenecks be? And what will the severity of those bottlenecks be out in the future? And at what point in time will they be bottlenecks, okay? And then part 3, or phase 3, is playing the what if game, and that is, once we've identified the bottlenecks, we want to do those imaginary games where we say, what if? What if we get another machine? What if we hire 3 more people in this department? What if we work overtime on these 3 machines? So you can do positive what ifs, increasing your capacity. You can certainly do negative what ifs. What if we shut down between Christmas and New Year's? What will that do to our on-time delivery? What if we take that big quote, right, that sales is looking at? And there's a couple ways of looking at that information. We'll talk about that when we get to it. Now, these phases build on each other, so it's important to have phase 1 done, that you do phase 1 correctly, and that you're successful in phase 1. And we'll talk about what success means in each of the phases as we go through. Let's talk about phase 1. Now, the first order of business in phase 1 is, if you do have an ERP system, to get hooked up to that, to be able to automatically bring your information over, so that you don't even need to think about it. So we have a seamless, what we call, integration platform where we connect directly to your ERP system. Whatever ERP it is, it doesn't have to be one of these shown here. We generally like to have an ERP that is on a SQL-based database, SQL Server or Oracle, for example, but it doesn't need to be. We have integrated with even some older type databases as well. But the idea is we're doing a read-only on your ERP, pulling out the work order, operation, routing information, materials, as we suggest if you're opting to bring those in through our integration platform and into SolidFlow for production management, scheduling, and possibly material planning purposes. Okay, so SolidFlow is up on the cloud. It is on AWS's GovCloud, so it's very, very secure, and performance is excellent. When we bring this information from your ERP, we also have the opportunity to transform it in such a way. We recognize that your data, no one's data is perfect, right? So you may want to transform it in certain ways, whether it's tweaking your estimated times, whether it's filling in a routing, maybe there's a step that isn't in your ERP that should be. Inspection often comes to mind. So when the routing does get over to SolidFlow, it is truly reflecting the way production happens out in your shop. Okay. This is also a net change integration, and it happens automatically several times a day. So once it's set up, you really don't have to do anything. It will, on an automated scheduled basis, it will look to your database for changes, new work orders, updates to existing work orders, and bring that information over into SolidFlow. Okay, very, very easy, very convenient. This happens very quickly. Within the first few days, we're connected and starting to establish the IP and do the exact mapping of information coming over. Okay, so this is an example of an on-premise integration. If you have an ERP and it's up on the cloud, oftentimes the question is, well, can you send information back? Typically, it's a one-way street, but yes, there are APIs and other methods. If you want to take information and send it back to your ERP, then you can do that as well. Okay. If your ERP is up on the cloud, and I've just selected Acumatica as an example of that, it is 100% cloud-based. There are others that are like that. It's not on your facility, you're just accessing it into the cloud. Then we connect to those too. And oftentimes the cloud ERPs are even easier, only in the sense that you don't need to go on-prem to a database. It's already up on the cloud. And typically there are APIs that we just link into to pull that information over. Now, once the information is over, and again, that's optional there as well. Once the information is over, so as I mentioned, and by the way, if you don't have an ERP system and really you're just out in production with spreadsheets, that's okay too. We have a full architecture that will support the creation of models that can be templates for work orders and work orders themselves. So don't worry. I will often refer to, and I'm going to assume most folks have an ERP and we're connecting to that. But if you don't worry. We have everything there for you to so you can create your work orders and have a place to hold them without needing a full-fledged ERP.
And I just want to chime in here where, that's one of the things that we looked at was we know that each customer is a unique situation, and some will have ERPs and some will be using spreadsheets, but that's why SolidFlow is so important, is because no matter what situation they're in, this is tailor-made for them to be able to really get to the next level of production. And when I first saw this, I remember thinking, well, who is going to support this? And we don't know the customers. And, this is something that's a little foreign to us, data management. And that's the other beautiful part of this, is that everything that you're seeing, okay, everything that you're seeing, Mark and his team are experts at. They live this, just like we live CAM. They live this stuff. And so when you find someone that where you mention production challenges and late delivery times and things like that, don't think that you're going to be, having to be the master of all this, and how are you going to put this into, production and support it. No, that's what Lillyworks does, and that's why they're such a fantastic partner, because we get the information to them, and they look for the pain points, they look for the best implementation. And I'll probably repeat some of this at the end, but I can tell you, we're not expecting the SolidCAM people to really be the experts in this. Of course, you can get as deep into it as you want, but this is a lifetime, of study that they already have, and you can really, really be confident that when you bring in a customer over to them, they're going to take excellent care of them, and it's just going to be another value-added service that you provide to your customer.
Thank you for that, Sean. Absolutely. And that is what we do. And in fact, even on a pre-sales basis. So really, if you're a SolidCAM reseller, or if you're a customer or client listening in right now, really all we need to know is, are you struggling with managing production out in the shop? Are you struggling with getting your orders out on time to your clients? That's all we need to know, and then we take it from there. Whether database will either once we sign NDAs, we can pull in an entire database and do the extract for you, or walk through that with you, just to pull together data for a demo, for example. We'll oftentimes do a full proof of concept where we'll take a full set of work orders. And again, this is without any commitment on the client's behalf. We'll take their full set of work orders and show what this environment would look like and how they would be managing production in their facility. So it happens quickly. We know what data to get. We know where it goes, and we know what to show and what's important as we walk through a proof of concept. So we'll touch, but thank you for that again, Sean. We'll touch on that again towards the end of the presentation as well. So as the information, once we're hooked up to the ERP, and as the information flows back over to SolidFlow, what we do here is create the execution plan. So this information is coming from the ERP. It's the routing steps, right? So what steps does this need to go through? What are the estimated setup and run times? We've got the quantity of the job. The due date is certainly part that's going to come over from the ERP as well. Also, actual completion information right here. So if we're going to assume that you're reporting operations complete in your ERP, again, if you're not, that's okay. We can do it in our tool. But if you are, we're going to capture that and show that information to you here, and I'll show you what that looks like in a moment. So here's the due date. All right, that comes over from the ERP. As a result of creating this execution plan, right? Remember, once we go through buffer sizing exercises with you and your production folks have told the system, and you can certainly change these over time, but initially, how big your buffers should be for different types of parts, different specific parts, even specific work orders, okay? So that you feel comfortable with that buffer time to get this work done. So as a result of that, you get that all-important release date that we've been talking about, right? So now we have a good objective point in time when we should start this job. And again, really, not much before, right? In order to enact Little's Law and make sure we're promoting flow on production. This is as I mentioned, that's the actual work that's been reported complete. So operation 10 and half of 20 have been reported complete in the ERP. This is today, this gray line right here, and this is the work that remains, right? This is the other half of 20, 30, and 40 that's still left to be done. And then from here to the end of the buffer is the time protection or the buffer remaining on this work order. So in real time, you can visually see the status of any job, where it is, and how it's tracking against its due date. This execution plan is also what is driving priority. The information from it is what's going to drive the priority. So instead of due date, what we're looking at, you probably guessed from the previous visuals here, is that we're going to take the percentage of the work that still remains, and we're going to divide that by the percentage of time protection remaining. And this creates a formula we call the threat level. So in layperson's terms, this is very simply which job, regardless of its due date and regardless of its lead time, whether it's a 2-day rush job, 2-week, 2-month, 4-month job, which one has the most work remaining percentage-wise, but the least time protection? Which job can least afford to wait longer in order to get your attention or the work center's attention to work on it, right? Which job is most in danger of being late? That is threat level priority. So the neat part about threat level priority is that you don't need to run a scheduling program to get it. It's always right there for you in real time. So we're going to take those priorities and publish them out where the work happens in production. And you could print them if you wanted to. But we like to promote getting these out in production in a visual way. This could be on a tablet, on floating tablets. It could be on a workstation. Many folks use big screen TVs. Could be 1 or 2 in the entire shop. Could be a workstation or a tablet for each department, even on each machine. And it would show for that machine or for that work center, or you could see across all your departments and all work centers, the priorities. And the one at the top is that job that is most in danger of being late. And that's the threat level priority right there. Okay. So everybody across in production, in fact, the whole company, everybody's singing off the same sheet of music, right? In terms of what job should we be working on right now? And it's very simply the one at the top of the list, the one with the highest threat level. Executing on this priority. Okay, so if everyone through the facility is actually picking the one on the top of the list and executing in this fashion, you will maximize your production's capability to deliver all your orders on time. Now, do you have bottlenecks? Are you going to be 100% on time all the time? No, not if you have bottlenecks. Okay, so this will be maximizing production's capability based on the capacity levels that you have. Okay, but what's important is that we're focusing not first on capacity and how we're going to maneuver orders to utilize the capacity. What we're focusing on here is very simply the priority. Okay, which job is most in danger of being late? Okay, so that's why this is so simple. It's easy to understand, but yet extremely powerful in its capability to allow you to deliver your orders on time as much as your capacity will allow. Okay, and this is really phase 1. This is the end of phase 1, and it's pretty simple. We connect to your ERP. That happens in days, sometimes faster. And we do some training with you. We do the buffer sizing exercises, and so that you can now see your priorities in real time and everyone executing. Okay. Now there can be some challenges here, right? So if you have production folks who have been in your shop for 25, 30 years, right, and they have their method of prioritizing that they're very proud of, right? And they've been doing for quite a long time, and it's worked for them in whatever context. Your company ships orders, right? So so there can be some change management, okay, we'll put it that way, that needs to go on here. So it's important, and we can help you with that as well to help show the production folks, not only so that they understand this, but actually that they're involved in perhaps the buffer sizing, they're involved in the implementation of this. They're involved in the priority setting and talking about it, so that they own it, so that they believe it. And oftentimes we've got some testimonials on our website. There's a couple videos of customers talking about doing this. One in particular talks about that, and how the operator would actually after they implemented this, they said, well, I never run this job before that one. Why is this telling me to run this job up on the top versus this other one? And they went back and looked back at it, and it was one of those, remember the long job, the 6-week, the due date, the 2 different due dates, which one should I work on next? And that was the situation. The operator never realized that the job he always ran first had a much shorter lead time, and the one he always put second had to go outside to external resources 2 times before it was back in for some finishing operations and then out. Okay, so once he realized that, then this made sense for him. This is also very, very dynamic, right? Without having to run a scheduling program. These are your real-time priorities, and they're the right priorities. So here's an example of a job down here, 10,005. It's very comfortable in the green zone, a relatively low threat level, and it's pretty happy sitting down there, not very much in danger of being late. Customer calls, the due date changes in the ERP, that gets passed over, and in real time, that pops up to the top. Why? When that due date is pulled in, now you're dealing with much less buffer time, much less buffer protection, and the threat level pops up to the top. Okay. So it's kind of self-expediting. Through every department that still needs to go through, that now will have a higher priority. You can also see how all your jobs are tracking. So this is what we call the heat map. So you can see all your jobs, or you can bring this up for a particular department or work center. Ideally, you want to see your jobs walking up this green zone on their way to on-time delivery. In the blue zone means, maybe we're starting jobs too early. Look, a few of these jobs have half of their work reported complete before the buffers even started, right? So here's the buffer time tracking down here. So that may be okay, but certainly if we're using resources or machines that are causing these to be late, then that may be problematic. And of course, the ones in the red zone are either trending late, or if they're up against the wall, they're definitely going to be late. Just to reemphasize, and folks, this is a different approach. It really is, and especially if you do have experience with the finite capacity scheduling model. Probably the hardest thing to shift in your mind, if you will, is that whole idea of, frankly, ignoring capacity in phase 1. That priority list that we were looking at, okay, this list by design and on purpose is ignorant of your capacity. Okay, and for some folks that's really hard to get over, but the point is, it doesn't matter if you have 6 machines, 60 machines, or 600 machines, right? And same with people. These are your priorities, right? How you execute on a day-to-day basis is up to you, but we're going to show you these are the jobs that are most in danger of being late. If you want to maximize your on-time delivery, the ones on the top of the list are the ones you want to be working on first, okay, regardless of what your capacity is. Okay. Now, so we don't take capacity into consideration in phase 1. Now, phase 2, that's completely different. Okay, but this is a very big mind shift. In the traditional scheduling model, you're looking at capacity first and trying to create that plan based upon your capacity. And frankly, that's part of the reason why that model is so difficult, because that in and of itself is a very, very difficult problem. Okay. So this kind of reverses the model. We're going to look at capacity later. For right now, let's isolate our priorities and make sure that we're always working on the right job, the right time, across all our work centers and all our machines. Okay. Phase 1 benefits. This is just phase. There's 3 phases to this, and this is just phase 1. And frankly, most of the benefits we see come out of phase 1, and they come pretty quickly. Really, what we're providing here is much greater visibility into the operational information, so that the folks out in production can make the right decisions in real time to improve the flow of materials. Okay. on-time delivery gets better, WIP becomes less because now you have a mechanism to control when and how much you're sending out into WIP. Your lead times become shorter. And again, this implements very quickly. Most companies go live within 6 to 8 weeks. So once we get started through some training, setting up the integration platform, looking at buffer sizing, publishing those priorities, making sure those priorities look right, typically a 6 to 8 week process to go live. Okay. We do have, if you're interested in or if you might look at an ROI, we'll show you some ROI points as we move along here, but we actually have a spreadsheet that covers time or cost savings. We've got another workbook in the same, or another sheet in the same workbook that covers additional added value revenue or contribution. That is, if you were using your same resources that you have today and that you're paying for today, right? The people in your facility, the overhead, the machines, how many more jobs, if you had true visibility of what job to work on next, and you knew you were always working on the right things, how many more jobs per week or per month would you actually be able to ship doing that? And what would be that value, right? From a revenue standpoint and or contribution standpoint. And this is having this visibility, right? Having this visibility and knowing this is a tremendous lever to grow your business. Okay? And you'll see how we can use this lever, especially in phase 3 in the what ifs, to see what actions you could take to increase your revenue, increase your profitability, your contribution margin in very short order to advance the growth of your business. Okay, that's all in just in phase 1. We've got an example of on-time improvement of a machine shop, about a $7 million machine shop. In October, they started out with their on-time delivery in the low 70s, and in very short order, just a few months, went well up into the 90s, and in 6-month time frame, they even had a couple months really at 100%, which is phenomenal. Your bigger shop, this is actually a capital equipment manufacturer that does have machining in it, but also a lot of fabrication, a lot of sheet metal work as well. Similarly, this company's on-time delivery was in the high 40s, low 50s, and over a few short months, they got it well up into the 90s, even hitting 100% at one week period. Okay. So the improvement comes fast, and it comes quickly. It's a fast ROI here. Okay, let's talk about this optional piece with materials. All right, and this is phase 1A with materials. So we looked at that work order, right? Here's the operation steps with it. Now, here's that material that I need, right? That could be bar stock, it could be titanium, it could be or something that's got a 90-day or 120-day lead time. But regardless, I want a firm understanding of when I'm going to need that material for not only this work order, but across all my work orders. So remember that picture. Here's my due date. Here's that work, and we added the buffer time in, so we have the execution plan. Now this is our release date, but it's also a really good point in time for our material need date, right? Because that is really when we're going to plan to start that work. I don't want to start it too much later because then I'm going to be eating into my buffer, but I don't want to start it too much sooner either because I'll be starting things too early. So this is a good point in time for when I need that material. And that's what we use from a material planning standpoint to show when you're going to need materials, okay? Again, just to use that extreme example, if I'm releasing things too early, if I'm planning to release this, in a crazy, as soon as possible, in this case, 20 weeks in advance, well, then that's when I'm going to need material, right? And that's just way too early to tie up that cash, tie up that inventory space for material if I don't really need it at that time. And again, we want material to flow, not get caught up in the traffic jam. Okay, so this is when we need material. Okay, it's right at the start of that work order. Okay. Now, we also support multi-level work orders. So for example, if in this case you've got 3 sub-assemblies that in this case need to come together in a welding operation. Now I've got these are sub-assemblies that need to be built specifically for this parent, right? And this parent needs it's got needs some materials at a final assembly, but of course it needs these sub-assemblies here, and these sub-assemblies need material back here. Okay. So instead of a single level execution plan, when you have a multi-level work order like this, you have a multi-level execution plan. So now I can see, here's my due date. Here on this assembly operation, this is when I would need those 2 materials right there for that final assembly. Okay, and again, not much sooner. And then for the materials on the sub-assemblies, I'm going to need those back here. So now I have a really good estimation of when I'm going to need all my materials. So notice each of these sub-assemblies is timed, synchronized, and buffered to make sure they're all going to get done for when I need them at that welding operation, from a convergence, all those materials converging together. Now, if you're making, if you're in a situation where you're making sub-assemblies on separate work orders, then we can help with that method too. So what we often see is if this is, say this is a bill of material, and say you've got some common sub-assemblies, these sub-assemblies need to be made for this parent, but also for others. And even this needs to be for this parent, maybe for others, maybe even for spare parts, right? So you have demand from different areas. What often happens is if those are all on separate work orders, which would make sense certainly if you're doing different lot quantities, but somebody, at least one person in the company, sometimes 2 or more, are trying to manage the due dates on all these work orders to make sure they're going to get done for whatever parents are going to need them. Okay. So what we can do is bring these work orders in and actually do a complete allocation and netting process, and actually change the update the work order due dates to turn this picture into that. So now we know that across all levels, which work orders are going to need to be finished and at what point they're going to need to be finished to feed the buffered demand for all of their levels up above. Okay. So really, really helpful if you're making sub-assemblies on separate work orders. The other challenge folks have where you're doing make to order orders, so some of these orders may have a specific due date on them for a customer, right? And others may just be replenishment orders into stock. Well, which ones are more important, right? You know, it may, on the surface, well, if it's got it's a customer waiting for it, that's more important. But on the other hand, if it's a make to stock, maybe that part is being fed into a subassembly that's tied to other orders, right, that need to get done. So it can be difficult to reconcile which ones, but that's what threat level will do. Threat level will show us from an objective standpoint which of these orders, regardless of whether it's tied to a customer commitment or to a replenishment quantity I'm going to need in stock, which one is most important to be worked on next. We can also see from a material visibility standpoint. So we've been looking at this priority list, and we can see all of the orders, all of the jobs or work orders that will be coming through a particular department, for example, that are either are there or will be coming through, right? But you can also filter that in a number of ways. And one of the ways is to say, just show me the jobs for which I should have material at this work center right now, right? And that's what this full battery shows. This shows just the 5 operations for which I should have, in this case, assembly operations, all the materials ready to assemble it, or if it were a machining operation, very simply the material, maybe the bar stock. Now, if it's a midstream operation, this could also mean just show me the operations or the work orders for which the previous operation has been reported fully or partially complete. So again, that I should have material here at this work center, and I should be able to get this started at the machine if I wanted to. Okay. And there are other ways to filter that as well. The other level of visibility you have is simply what is my material visibility, from an inventory standpoint to do this job. Okay, so we have what's called a shortage indicator light that's part of the priority list. So green means I don't have any shortages. I have all the materials in inventory. If I wanted to build this right now, I could go get the materials out of inventory and build it. They're there. Yellow means I have some shortages. So in this case of 1 out of 4, in this case, 8 of the 59 materials I need to assemble this thing are short. And red means all the materials are short, in this case, just 1. But in any case, in any of these cases, I can click on it and then drill down and see the details. So I could see all of the 8 shortages. In fact, I could see all 59 of the items required here, and then see how they're going to be allocated, okay, how they will be allocated for this job, whether it's from inventory, whether it's a manufactured part coming in from a work order, or whether it's a purchase part coming in from a PO. Okay, and in any case, whether it's short or not, if it's short, then I'll see the incoming supply, and I can see the status of that supply. If it's a PO, when is it coming in? If it's a work order, not only when I want it to come in, but where is it right now? In other words, what's the last operation that was touched, that was reported some completion on that work order? So I should be able to go see if it's bottlenecked somewhere or if it's stuck in some department somewhere. Okay, that was phase 1, execution, and then also the optional materials. Let's talk about phase 2, looking into the future. Okay. Now, for looking into the future, instead of running a scheduling program, okay, what a solid flow does is it will actually do a simulation of you and your production folks executing off of these priorities out into the future. And it will actually see what each work orders, what each operation's threat level will be in the future, and make the appropriate decision at that future moment in time in terms of which job should be placed on that resource in that department. Okay, so let me walk you through that. And literally, this is how the program works. It starts and sees, what is my production execution list? What is my priority list? I'm going to pick the one that needs to start next. That's job 10,002. Then it's going to go down to this department down here. There's nothing there, so that's fine. Now this job will get started, and so on and so forth, and simulate how all the work orders will be executed out in production. So you can see here's and I'm just stopping here. Of course, the program wouldn't stop, but here I've just finished this operation, this work order in this department, and now I may have several work orders waiting to be executed here. So once this will free up in the future, which of the work orders will be placed in this department? Well, it will be the one that will have the highest priority at that future moment in time, and that's going to be 10,005, and so on and so forth. Okay, so that's how it does its simulation. So at the end of the simulation, it's not really a schedule in the sense that we're not going to take this and go ask folks to execute against it. In fact, we don't need to do that. We always have our real-time priority list, so we know what to do next. But this does give us a really nice indication of where our bottlenecks are going to be, right? And the severity of those bottlenecks. Clearly, resource B will be a bottleneck. There's no white space in between there, okay? There was contention, and we can also see how much contention there will be in each of these bottlenecks. By contention, I mean wait time. How long did each operation, or will each operation have to wait in order to get its turn at the department or the resource it will need in the future, okay? So you can also drill down and look at it by work order. So here's that execution plan we were looking at before. Here's today, here's the work that remains. Theoretically, I've only got 2 days of work left to do here. I could get these 3 operations done by Thursday in just 2 days. But because I have other priorities in the shop as well, I've got tens or hundreds or thousands of other work orders, I'm not going to be able to get to these priorities won't get to the point where they will be worked on perhaps until out here. And the reality is, based on all the jobs I'll be working on, this isn't going to be able to get done until 2 days late. Okay, so I can see where they're predicted to start and finish as well. Okay. So this simulation program takes into consideration capacity in a big way, right? From calendar and time capacity, your machine capacity, even people capacity, material, if you decide to bring material into the picture as well, even tooling. Okay. And again, when you look at this is simply the results of having run the simulation, and shows you where your bottlenecks will be in the future, the severity of those bottlenecks, where each operation on each job will be predicted to start and finish. And if I click on one of these, it will highlight all the operations of that job. It will bring up the execution plan for it and show me specifically where, when, and why each of these operations is predicted to finish the way it is, based on all the other work and what all the other priorities will be out in the future. Okay. So the really neat part about this is, if you're truly executing this way, all this is doing is simulating the way you will be executing out in the future. So the results of this is quite believable from that perspective. Okay. Sales is going to be comfortable taking this information and giving the customer an update. Now, whether they want to be truthful is another thing. Maybe they don't want to bear some bad news, but they will have a good indication of what their times to completion are going to be. Okay. We take that predicted days of lateness and we use that as well in a number of ways. So here's the information. Here are your work orders, the due date from your ERP. We're going to calculate the predicted finish date. We'll do some date math and show you the predicted days of lateness for every job out in the future. So you can sort by that certainly and say, what this one's my most, 13, and drill down into that, see why that is. Is it going to be caused by an internal constraint, a machine bottleneck, a person bottleneck, or maybe even a material problem? Okay. You can summarize that information by department, so I can see which one of these resources will have the most predicted wait time in the future. That is, which machine will be my biggest bottleneck out in the future, and that's really nice to understand and verify, see the severity of that bottleneck, and then you can start thinking about doing some what ifs from there. Okay. So here's some predicted wait time graphs, so I can see over time, whether it's weeks or months, how much predicted wait time I'm going to have across all my orders, and then you can drill down on that and see which orders as well. Okay. What's also fun is if you can bring your financial information, your revenue information into the picture as well, either by actually bringing in your sales orders, and it will do this automatically, or you can assign revenue to jobs and do it that way. But either way, you can get a picture like this. Now, this is a monthly basis looking out in the future, showing me how many dollars I would be able to ship if I were able to finish all my jobs on time. Okay, so this is the future dollar revenue or contribution margin that I would be able to generate through my company if I were to have 100% on-time delivery. Now, we know that's probably not realistic. We're hopeful, but probably not realistic. Where you are now is because if you were talking to us about improving it. So if you then run it based upon the predicted finish dates, then you get the more accurate picture of what it actually looks like. But the beauty of this is now you can see what your potential is versus where you are today, and you can see there's a significant opportunity for improvement here, and even just a small improvement is going to hit my bottom line in a very positive fashion. Okay, so we'll see what that looks like when we get into phase 3. You can also see kind of a work order status board, we call it, and this is showing here again, in this case, I've got a lot of lateness out there. I've got a lot of jobs that are predicted to be late. Here's when I want them, but they're predicted to be this many days late. Okay, and we're going to bring this into phase 3. as well. So phase 3 is where we've identified the bottlenecks in phase 2, and now in phase 3 we're going to do those what ifs. Okay. So what can you change in a what if? So you have your primary, we call it a game plan. You can change the overall calendar, your site calendar. You can change your calendar by resource or department. So you can say, what if I just work overtime or work 3 shifts on these, 3 or 4 machines? You can change the priority mode. Actually, there are override priorities to threat level. We don't necessarily recommend using that extensively. Threat level is the best way to go to maximize your on-time delivery, but certainly if you have certain customers or certain jobs that you want to prioritize over all others, or under all others for that matter, then you can do that. Here again, you can modify by department, by work center, by machine, the calendar itself. And then you can change the nature of resources. So you can say if you have a group resource, for example, how many people are in the group? What if I add people? What if I subtract people? What if I add machines? Right? So what if I added 2 or 3 machines in this department? And you can also put time factors in it. So I'm not going to be able to get the machine for another 60 days. So start the analysis at that 60-day point. Okay. And then you can get right down to the work order level and say even which work orders to include or exclude, do what ifs on their due dates, do what ifs on their priority overrides. So you can also, this is also the way you include quotes. So you could send a quote over from your ERP in the form of what we call a proposed work order, and that you can look at what if a couple different ways. You can say, I just want to try to fit this in, so don't move any of my other jobs priorities, just use available capacity to kind of fit this in. When would I be able to get this quote out? Or you could say, no, it's a really important customer, we need to have this out in 3 weeks, set a hard 3-week target date on it, and just show me what that's going to do to all my other jobs. Okay, the predicted wait time, as I showed before, can be summarized. It can be broken down into time frames. So I'm looking at a couple different what ifs. Here's the predicted wait time on my primary game plan. If I take that big quote, my predicted wait time is going to go up. So you can see the increases here. If I come in and work Saturdays, though, my predicted wait time is going to drop. Okay, and then you can drill down into these to see which work orders you will be able to get out on one game plan versus another. So here's that original work order status board where on our primary game plan, once you run a what if, you can bring this up under a what if game plan. So here's what it would look like if I came in on Saturdays. Notice a lot of redness was reduced. I have a lot more green now, and the overall length of the duration of the jobs are much shorter as well. So my days of lateness is reduced by doing that what if. I can bring up those results visually here as well. Okay. When we go into comparative game plans, this is where we can quantitatively see the differences between our standard game plan and any what ifs that we do. So here I've got a standard game plan where I had, I think, 510 days of lateness in the month of November. I will have, and then if I do my work overtime, so this company worked 4 10-hour days, Monday through Thursday. So we said, what if you come in Fridays? Not in the whole shop, just in that bottleneck department. How much will that reduce your overall lateness across all your work orders? And it reduced it down to 415, which is almost 100 days of lateness. So you can drill down and see the actual math and see what the delta is. Okay. Similarly, you can see this information based on the value, as I mentioned. So again, that can be done by either bringing in your sales orders, and it will do a soft allocation of what work orders are tied to the revenue in certain work orders, or you can assign value to work orders. So this is showing very nicely what my standard game plans projected revenue or contribution margin will be in the future. That's the dark blue. And you can see if I, now this is kind of an extreme example, but if I go up to 3 full shifts 5 days a week, then you can see the additional revenue that I'm going to generate on that on a month-to-month basis. And then actually bring up the values here, okay, showing the difference, showing the delta per month. So while it sounds extreme, gee, if this is a contribution margin number, that means that this would be the additional profit I'd be able to generate in my company by making this production change, and this value would go directly to my bottom line. So while, yeah, might have some cost adding another shift, the payback may be significant enough to warrant it. But at least we have the visibility to make that decision. I have gone over. Thank you for your patience. I hope you've been able to stay. And I'm certainly open to taking any questions that you may have. We do have information on our website as a 3-minute video. There are a number of case studies, either in video or written form. And if you're interested in looking at this further, we can have a one-on-one discovery, about a half hour, to talk about your challenges. And then certainly if we get there, look at doing a full proof of concept where we take your data and essentially walk through these 3 phases with you, showing you what it would look like in your facility.
Well, thank you, Mark. That was really, really extremely interesting. And like I said, this is a historic day for SolidCAM because it really takes us to the next level of customer support and really getting, a way to ease their pain. And we know that scheduling issues are, one of the major pain points. So I do want to speak to the customers that or prospects that may be on this call. You simply get in touch with your SolidCAM team, and our team. As far as that goes, look, if you find someone that is interested in the solid flow, just consider solid flow like your technical team. Like we have specific technical teams that handle things like advanced mill turn and Swiss. Well, solid flow. For that, we have Lillyworks as our technical team and sales team that will handle that. So you'll be in the best possible hands. And again, just like SolidCAM does CAM, Lillyworks does this protected flow manufacturing. It's unique in the industry, and I'll just do a quick summary in that whether a customer has an ERP or not have an ERP, it does not matter. This is something that would benefit just about any customer. It's unique in the industry, and again, there's no one better in the industry than Lillyworks. So this is another real dedication to customer satisfaction that that SolidCAM has. We are also launching the solid metal marketplace, where we'll be able to have customers basically have their own site within our site, and they'll have their own show place within our site. And then we're also going to be doing some additive manufacturing. SolidCAM is going to and is now, we're used to taking away challenges, and we're going to be easing more of those challenges. And again, solid flow is the one I'm most excited about, because I've seen ERP out there, I've seen scheduling software, and I've seen some of the real challenges that most companies have. So this is a fantastic marriage. 2 companies that could not have a better working relationship, and could not be closer. So from a customer prospect, thank you for joining us, and you should feel very very excited about solid flow, protected flow. I know I would. And for those people that are the SolidCAM employees, this is really another great way to take away those challenges that your customers experience each and every day. So Greg, I'm looking for Mark, I'm looking for questions. I'm not seeing that any questions in here so far, but if you do have a question, please type it in, or just contact your SolidCAM person, and they will take it from there.
Awesome. Thanks, Sean.
Okay, well, thank you all. This is being recorded, so we'll get this out to everybody that's on this presentation, anyone who signed up. And I thank you all for attending. It was, I know, again, it was very full of information, and I'm full of enthusiasm for the next step in SolidCAM's dedication to customer satisfaction. Take care, everybody, and thanks for joining us.
Thanks, everyone.